Now we are on to life cycle models in software engineering. And as we have discussed earlier that we are going to see few revolutionary and marked models. So first is classical waterfall model. And this classical waterfall model, it divides the life cycle into phases. As we know that life cycle means different phases and in between various activities are being carried out and they have proper exit and entry criteria. The first one in classical waterfall model is feasibility study. Then we have requirements analysis and specification, followed by design, then coding and unit testing, integration and system testing, and finally the maintenance part. Waterfall model has actually extracted its name from a similarity or some sort of uh, similarity between the waterfall, actual waterfall in real life, and in its workability. Like you perform feasibility study, then requirement analysis, followed by design, coding, testing, and maintenance. So water is falling like this, okay, and water cannot go back. Water cannot move back because of gravity. This shows that the requirement analysis cannot be redone. If we are on design phase, requirement analysis is once for all done. This is the relative effort of requirement to maintenance. The phases between feasibility study and testing, we call them as development phases. And among all these life cycle phases in classical waterfall model, maintenance phase, it consumes the maximum effort. As it is evident from this bar chart that requirement specification takes very less effort while maintenance consumes the maximum effort. Testing phase, again, in development phases, in terms of development phases, this testing consumes the maximum effort. So between feasibility analysis and testing, if we consider testing, it consumes the maximum effort. Various organizations, they try to define standards on the output, that is deliverables which is produced at the end of every phase. And again, let me reiterate that entry and exit criteria for every phase is defined. And they also prescribe certain methodologies for specification, design, testing, and project management. Various other things are also involved. The guidelines or the policies or the methodologies for an organization, which is called as organization software development methodology. This one. So software development organization, they want or they would expect fresh engineers, the freshers, to master the organization software development methodology. What about this feasibility study? Feasibility study, the main idea or the aim of feasibility study is to determine whether the development of the product is financially worthwhile. Means where we are trying to assume the economical part, then is it worth to make the software? And second, if financially worthwhile, we also have to check whether it is feasible or not. We put in a lot of money and technically it is infeasible. Then we roughly understand what the consumer is expecting from the product. Means different data which would be the input to the system, what processing are to be performed on this data, what output data the system is going to produce, and certain constraints on the behavior of the system. So what are the activities during feasibility study? First is overall understanding of the problem. Problem not understood or misunderstood will lead to a product failure or project failure. Then what may be the strategies to solve? So we formulate the strategies. Then examine alternate solution in terms of what? Maybe required, the resources that may be required, the cost which is involved for development, and the time, the schedule, the development time. Then we perform a cost benefit analysis. Cost benefit analysis. Why? Because we have found various solutions or various modes can be uh, taken up to solve a particular problem. So which one is the best? For that we perform cost benefit analysis. And you may also determine that none of the solution is feasible. Maybe because of cost, maybe because of the constraints of resources or some technical reasons. Then comes the requirement analysis and specification part. What is the main key of this phase or the aim or the idea? First, to understand the exact requirements of the customer and then to document them, then to put them in ink, black and white. So we have two distinct activities. First is requirement gathering and then analyzing it and then specifying the requirements. That is requirements specification. What are the goals? What we are going to achieve after requirement analysis? First, to collect all related data from the customer and then analyze the collected data to clearly understand that what this customer is expecting. If any incompleteness or inconsistency are there, we need to find out here itself. And then we need to resolve them. Just by finding these problems is not going to work. We have to resolve them also. Then comes the requirements gathering part. Gathering the relevant data, which is relevant. Usually collected from the end users, maybe with in person means talking to them, having discussions, interviews. Just for instance, a business accounting software. All accountants are interviewed. They are interviewed to find out their requirements, their thoughts, what they would require. And then the data you initially collect, maybe from the end users. They may have various contradictions and also they may be ambiguous, so may contain ambiguities. So each user typically has only a complete or a partial idea of the system or a view of a system. So these ambiguities and contradiction must be identified and they need to be resolved by sitting with the customers, discussing with them. Then the requirements are organized in certain form of document which you call as software requirement specification. So engineers or software people doing requirement analysis and specification, they are known as or they are termed as analysts, software analyst, because they are performing requirement analysis. Then comes an important part which is design. Often well thought, well planned, well managed, it has to be. Design phase transform these requirement specification by the analysts into a form which is suitable to implement in certain programming language. If we talk in general terms, but in design, we talk in technical terms. So during design phase, software architecture is derived from the document software requirement specification document. Software architecture is derived. There may be two design approaches. First is a trivial or traditional approach. The other may be object-oriented approach, which is mostly followed. Traditional design approach, they have two activities like structure analysis and structure design. Structure analysis activity, what it does, it will identify all the functions to be performed and identify the data flow among these functions, the processing stations, and then decompose each function again and again, that is recursively, into their sub-functions, and then again find out or identify the data flow among the sub-functions likewise. What about structure analysis? These are carried out with DFDs, data flow diagrams. And after this completion of structure analysis, we carry out structure design. First is architectural design. We call it as high-level design, or the next one will be detailed design or low-level design. What is high-level design and low-level design or detailed design? High-level design, it decomposes the system into modules and represent invocation relationship among the modules. Means finding out the modules or decomposing the system into different modules and then finding out the relationship which these modules they have between one another. Then detailed analysis, what it contains, or what do we mean when we say detailed design? Different modules design, they are designed in much greater detail. So data structures and algorithms for each modules, they are designed. Here the data structure and algorithm parts come. Then first we identify, in case of object-oriented design. We have just discussed about the previous trivial or traditional approach. But in design which is object-oriented, we first try to identify various objects, that is real-world entities, which are there or which are presenting the problem. Then, of course, once the objects are found, the relationship among the objects is to be ascertained. Just for example or an instance, a payroll software may have object as employees, managers, payroll register or departments, and there are various others. So object structure, that is again further refined to obtain the detailed design. This object-oriented design has various advantages. It has lower development effort, lower development time, and then easy to maintain, so better maintainability. Then we arrive at implementation part. Here the purpose of implementation phase, also known as coding and unit testing phase. So we perform coding and unit testing here itself. So here we try to transfer our design into actual source code. So translation of source design into source code is what we call as implementation. And in this phase, implementation phase, each module of design is actually programmed or coded. Then each module is unit tested. They may be independently as standalone unit and they may be debugged. And then each module is to be documented. And why we are, pressurizing or emphasizing on unit testing? Because we test if individual modules, they work correctly, independently. And the end product of the implementation phase would be the set of program modules that have been tested individually, or unit testing has been performed thoroughly. Then comes the integration and system testing part. So different modules are integrated in a planned manner, well-organized manner, and modules are almost never integrated in one shot. Not once, means they all are not combined in togetherness. So normally integration is carried out through a number of steps, one combined with second, then third, and likewise a grouping of modules can be done. And during each integration step, the partially integrated system is again tested. Like this, we made a module, the second one, the third one, and the fourth one. This is how we combine them. Then comes the system testing. What is this? System testing? When all modules have been integrated properly and tested, then we perform a final testing which is called a system testing. This is a system testing. Why we perform system testing? Just to ensure that developed system functions are according to requirements as specified in the SRS document. Then comes the part which is taking the maximum effort, which is our maintenance part. So maintenance of any software product, it requires much more effort than the effort to develop the product itself. Okay? The development effort to maintenance effort is typically in the ratio of 40 to 60. We have various types of maintenance: corrective maintenance, perfective maintenance, and adaptive maintenance. What is this corrective maintenance? It tends to correct the errors which were not discovered during the development phase. Perfective maintenance, we try to improve the implementation of the system or try to add up, enhance functionalities to the existing system. Then what is adaptive maintenance? We port software to a new environment, that is to a new computer or to a new operating system. So this is adaptive, adapting to the present scenario. Life cycle models, we have just seen this waterfall model called as classical waterfall model, and this model or the classical waterfall model was the basis and is the basis of all the models which we are presenting now and discussing now. So what is now iterative waterfall model? Classical waterfall model is idealistic. They are idealistic. It assumes that no defect is introduced during any development activity. It also says that the defect will be only found out in the testing phase. But in practice, defects do get introduced in almost each phase of the life cycle. This is a reality. So defects, they usually get detected much later in the life cycle, which is not expected and not agreeable also. Just for instance, a design defect might be unnoticed until the coding or testing phase. A design failure can cause a project failure. But once a defect is detected, what we need to do, we need to go back to the phase when it was introduced, again redo some of the work done during that and all subsequent phases. That is why we are calling this as iterative waterfall model. So we need to have feedback path in this classical waterfall model, like this. We had feasibility study, requirement analysis, design, coding, testing, and then maintenance. And then we have these feedback paths. Okay, these paths are there. Errors should be detected in each and every phase wherever they are introduced. For instance, if a design problem is detected in the design phase itself, the problem can be taken care of there in that phase quite easily. Then say if it is identified at the end of the integration or system testing phase. Then phase containment of errors. The reason being, we need to rework. That is, rework must be carried out not only in the design phase. If the problem is in design phase, we have to rework in coding and testing phases as well. The principle of detecting errors, which is what we wanted to be very close or as close to its point of introduction, this is known as phase containment of errors. Iterative waterfall model is by far the most widely used model. Let me reiterate or tell you that this model, iterative, is the most widely used model. Almost every other model is derived from this waterfall model only. Okay. But irrespective of the life cycle model actually follow, the documentation should reflect a classical waterfall model of development. And the comprehension of the documents should be facilitated. We need to present the metaphor of a mathematical theorem which proves that a mathematician presents a proof as a single change of reductions. But even though the proof might have come from a convoluted set of partial attempts, bind delays and backtracks, what it means? It means that we need to see and try some arrangements that the error should never come in the later phases. The error should have, or the containment of error should be close to that point where we can easily remove it, and the propagation of error should not be there. Now we are coming to prototyping model. What is this prototyping model? Before starting actual development, we prepare a prototype, right? We build a prototype of the system. This is just a toy implementation of a system. If we try to analyze or make an analogy with respect to a building, we make a prototype. We make a model first. And this toy implementation has limited capabilities. It is not reliable. The performance is also not good. Why we need to develop a prototype? What are the reasons behind it? First, we need to show it to the customer, illustrate or demonstrate to the customer. We need data formats, messages, reports, or interactive dialogues, which should be there so that he can understand what is going to be built. And then also some analysis and examination of technical issues which are associated with the development of the software product. So there will be some major decision or major design decision with response time of a hardware controller, or some algorithm is there and we need to find out that whether the algorithm is efficient or not. The third reason for developing a prototype is you can't get the thing right at the first time. You must plan to throw away the first product if you want to develop a good product. So start with the approximate requirements, carry out a quick design. Prototype model is built using several shortcut methods like inefficient, inaccurate, or dummy functions. The function may use, say, table lookup rather than performing the actual computation. The developed prototype is then submitted or given to the customer, presented to him for evaluation, and he gives or he returns some feedback or requirements and they are refined. This cycle continues until the user approves the prototype. And the actual system is developed using the classical waterfall approach. So prototyping is done, and all this prototyping will end up with the final development employing your classical waterfall approach. So requirement gathering, quick design, evaluation by user, refine requirement, again build prototype. This circle goes on until customer is satisfied. Then we design, implement, test, and maintain. Requirement analysis and specification, it becomes redundant because final working prototype with all the user refinement which has been given as a feedback serves as a animated requirement specification. And this design and code for this prototype is usually they are thrown or they are scrapped. The experience gathered is important for development of this prototype. It helps a great deal while developing the actual product. The construction of working prototype model involves additional cost. This is there. But the overall development, it might cost lower because system with unclear user requirement, system with unresolved technical issues is never accepted. So many user requirements get properly defined here and technical issues are resolved properly. and these would have appeared later some in change request or maintenance phase and resulted in incurring massive redesign cost. Then we have evolutionary model. What is this evolutionary model? Also known as successive version of incremental model. So incremental model, evolutionary model, they are similar. The system is broken down into several modules, several paths, which then can be incrementally implemented and then delivered. We develop the core modules, the basic modules, important modules of the system. The initial skeleton is then refined with increasing level of capability. That is, we want to add now various new functionalities in successive versions. And the successive version of the product. Functioning systems, they are capable of performing some useful work. A new release may include various new functionality. Existing functionality in the current release might have been enhanced. This is also possible. So diagrammatically, we can show we have A here module, we add B here, we add C here. This is how evolutionary model or incremental model works. What are the advantages of evolutionary model? First, user get a chance to experiment with a partially developed system much before the working version is actually released. And it also helps in finding out user exact requirements. Again, much or well before the working system is developed. These core modules are again and again tested. So this reduces the chances of any errors in the final product. But often difficult the disadvantage is difficult to subdivide problems into function units, which can be incrementally implemented and delivered. Evolutionary model is useful for very large problems, when it is quite easier to find these modules for incremental implementation, not for small problems. What about evolutionary model with iteration? This version. Many organizations use a combination of iterative and incremental development. So a new release may include new functionality. Existing functionality from the current release may also have been modified. There are several advantages of this. Training can start on an early release. So customer feedback, we can get customer feedback and that can be shared and taken into account and be incorporated. Markets can be created. That's for functionality that has never been offered. So once the user is glued to your software, now you can add with amount, with some fun. So frequent releases allow developer to fix unanticipated problems quickly. Then we come to spiral model. It was proposed by Boehm in 1988, and each loop of the spiral, that is why we call it as a spiral, that it represents a phase of the software process. The innermost loop represents the system feasibility. It is quite concerned with the system feasibility. Then comes the next loop, which is software requirements definition. The next one will come as a system design, and so on and so forth. There are no fixed phases in this model. The phases shown just now are just examples. I'll show you just now. The team must decide first how to structure the project into phases. This is very important. And then start for using some generic model. That is, you can add extra phases just for some specific project when problems are identified during a project. And each loop in the spiral, which I'm going to show you just now, is split into 4 quadrants or 4 sectors. This is spiral in the shape of spiral. We need to determine the objectives, identify and resolve risk, then develop next level of product, and then customer evaluation of design. So this first may be requirement specification, then you have feasibility, requirement specification, design, and so on and so forth. What is the objective setting in first quadrant? This one. Identifying objectives of the phase means examining the risk associated with these objectives. Risk, what are these risks? Any adverse or unacceptable circumstances that might hamper the successful completion of a software project. And then finding the alternative solution possibility. What about the second quadrant, risk assessment and reduction? For each identified project risk, we create a detailed analysis. We carry out a detailed analysis. And then we take steps to reduce or minimize this risk. Just for instance, if there is a risk that the requirements are inappropriate, a prototype system may be developed. Then, develop and validation, third quadrant, we develop and validate the next level of the product. Then fourth quadrant, we review and plan. We review the results which are achieved so far with the customer, and we plan the next iteration around the spiral. And with each iteration around the spiral, we progressively, we make complete version of the software which gets built. What about the spiral model as a meta model? It subsumes all discussed models. A single loop spiral represents waterfall model. If you use an evolutionary approach, iteration through the spiral are evolutionary levels. It enables understanding and then prompt reaction to the risk during each iteration along the spiral. And what it uses? The uses are prototyping as a risk reduction mechanism and retaining the stepwise approach of the waterfall model itself. So, what about the comparison of these different life cycle models right from the classical to spiral? Iterative waterfall model, it is most widely used model, but suitable only for well understood problems. But prototype model is suitable for projects not well understood. User requirement and technical aspect. If this is not well understood, prototyping model is good. Evolutionary model, this is suitable for large problems. And we can decompose into set of modules that can be incrementally implemented. And incremental delivery of the system is acceptable to the customer. Then we employ evolutionary model. And spiral model, it is suitable for development of technically challenging software products that are subjected to several kind of risks. So risk analysis and risk is the basis of spiral model. So this is a complete overview of various life cycle models, and which is most AUA, which is not. I hope you got an idea that these are the life cycle model, how life cycle goes for a software. Thank you so much. Take care of yourself.